Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times. And if we had an array 1, 2, 3, this array would then become, after one rotation, it would become 3, 1, 2. So all we're doing is we're taking, on a rotation, we're taking the last element in the array and putting it in the front. So that is how rotation works in this problem. Now, when given the sorted array nums of unique elements, so every number in here is going to be a unique number, return the minimum number in the array. And we must write an algorithm that runs in O of log n time. So O of log n basically means as the size of n gets double in size. So as n doubles in size, let's say n is 2, then n is 4 elements in the array, then n is 8 elements in the array. Our time to complete our algorithm is only incremented by 1. So as we see, this is a great time complexity because as n doubles in size, we only have one more time unit, one more iteration to do to find the answer. Okay, so now let's look at an example array and get started on creating our algorithm. So a couple things to note here. Our array is sorted, our array is rotated, and our array has no repeating numbers. And as we iterate through this array, we want to remove half of the elements on each iteration so that we can keep that O of log n time complexity. So the way we can solve this is by having a right pointer and a left pointer. So a right pointer will be at the very right of the array, at the very end of the array rather, and the left pointer will be in the middle of the array. All right, so let's start chopping down our array. The first thing we're going to do is check to see if our left pointer here is less than our right pointer in terms of their values. So is 2 less than 7? In this case, 2 is less than 7. And so what that tells us is that we can we can delete from this array everything to the right of 2. Everything to the right of 2. And the reason we can do that is because we know that the array, while it is rotated, it's still in ascending order. So therefore, all of the numbers between 7 and 2 are going to be less than 7 and greater than 2. And since we're looking for the smallest number, we know that we can just get rid of all those numbers out of our array. All right, so that is our first iteration. Now let's do our second iteration. So we've cut our array by half, and what we're going to do is then set our right pointer equal to the length of the array minus 1 because we're accounting for the array's zero-base index. And then we'll set the left pointer to the middle value again. Okay, and so now that we have these set, we will check, is 10 less than 2? And 10 is not less than 2, which means that 10 is greater than 2 because there are no repeating numbers in this array. So 10 is greater than 2. In that case, what do we do? Well, since 2 is less than 10, we know right there that our array has been rotated, right? Because in a naturally ascending numerical array, the numbers would go from least to greatest. But here we've got a number that is smaller than another number to the left of it. So it must have been rotated, and therefore it must be smaller than 10 and every number to the left of 10. So what we can do on this iteration, if our left pointer is greater than our right pointer, we can delete the value of our left pointer and everything to the left of it. Okay? And then we want to set our values again. We set right the right pointer to the last element. We set it as the last index of the array, and it represents the last element. And then the left pointer is going to be set to the first element in the array. And the way we're getting this left pointer throughout this whole process is we're taking the length of the array, dividing it by 2, rounding up if it is an array that has a odd number of elements, and then we're subtracting 1 to account for an array's zero-base index. All right, so we go through our third iteration, our third chop of this array, and we say is the value at left is 11 less than the value at 2, or the value at r, which is 2. So it's 11 less than 2, and it is not. So we already know what we can do. If 11 is not less than 2, it means it's greater than 2, and therefore we can remove it and everything to the left of it. In this case, there's nothing to the left of it, so we simply remove 11. And then we're left with 2. And we can break out of this sequence, this iteration, this loop of continuously getting rid of numbers in this array when there's only one number left. When there's only one number left, we can pop out of our loop and return this number. All right, so is our algorithm O of log n time? We have 10 elements in our array, so nums has a length of 10, n equals 10. And let's see how many iterations this took. So we had our first chop, our first big deletion of numbers in the array, and then we had our second over here, and then we had our third right here. So while n is 10, this took us 3 iterations, 3 time units to complete. And this is an O of log n time complexity. So we did it. This works. And now let's take a look at our space-time complexity. So we will remove this, and let's look at our space-time complexity. So space-time complexity, our space is very good here. We have 2 pointers, left and right, and they both take up constant space. So our space is O of 1, constant space complexity. And then our time is going to be, as we just looked at, is going to be O of log n, O of log n time complexity. And again, that's because as the size of n doubles, our time only increments by 1. And so there we go. We have finished our algorithm to solve this problem. Now, before we go, let's take a look at this array on the right side that has 2, 3, 4, and 1. So this is a sorted array, and it's rotated by 1, 2, 3. So it's rotated 3 times. In this case, what if we didn't want to have our right pointer at the very right and our left pointer in the middle? What if we wanted our left pointer at the very left and our right pointer in the middle? Well, this would become problematic because we don't know enough information if we set up our pointers in this way. We can do our check, so we can say, is the value at left less than the value at right? Is 2 less than 3? Yes, it is. But does that mean that we can then cross out 3, 4, and 1? Well, it doesn't, because 1 is less than 2. And therefore, we are losing our smallest number, which is the number that we want to return. That's why we must start with our left and right pointers on the middle and the outermost element, respectively. All right, so let's jump into our code editor and code these out. Let's implement our JavaScript solution first. So first thing we want to do is set our left and right pointers. Left is going to equal math.ceil at nums.length divided by 2 minus 1. And the reason we're setting it to this is because let's say we have an array of length 4 and another array of length 5. If our array was of length 4, we want to set left equal to this indice right here, to the left middle indice. So these are both the middle indices, but we want to do the left middle index. And if an array has an odd number of elements, we want to set left as the middle indice. So this middle, it will represent this middle value here. And math.ceil is the key to making this all work. So let's see what's happening here. Nums.length, which is 4, divided by 2 equals 2. And then we run math.ceil on that. 2 rounded up, there's no decimal value, so there's nothing to round up here. Math.ceil is a built-in function that rounds up any decimal value to the nearest whole number. But since there's no decimal value, it doesn't do anything to it. And then we subtract 1 from it to account for array's zero-base index, and that equals 1. So our index of left here is going to be 1. And as we see, that is exactly what we wanted to get. Now let's do the same thing here. So a length of 5 divided by 2 is equal to 2.5. And when we run math.ceil on 2.5, it rounds it up to 3, the nearest whole number, or the next whole number. And then we subtract 1 from it, which gives us an index of 2. If we look here, we've got 0, 1, 2. Perfect. So in the case that our array is even, it's going to be the left middle index. And in the case that our array is odd, left is going to be set as the middle index. So that is why we set left equal to this value. Then we want to set right. And right is equal to nums.length minus 1. So we're simply setting right to the last index of the nums array. Now we want to create a while loop, and we want this loop to continue running while nums of length is greater than 1. If nums of length is greater than 1. If nums of length is not greater than 1, well, then that means we've deleted all the bigger numbers out of our array, and we can simply return nums at 0, because our array will only have one element. It'll be this one number at index 0, and it'll be the smallest number of the array. Okay, so now let's run our checks inside of here. And we want to see if nums at left, is nums at left less than nums at right? And if so, we want to delete every element to the right of our left pointer. So how do we do that? Well, we can use nums, we can use the dot splice method, which is a built-in method in JavaScript. It takes in, when you pass in 2 parameters to it, it can take more than 2 arguments. But when you pass in 2 arguments, the first argument is going to be the index that you want to start deleting at. And so we want to set that index as left plus 1. And then it takes in the amount of characters or the amount of elements in that array that you want to delete. And we want to delete all of the elements from of left plus 1 all the way to the end of the array. So we can take right minus left, and this is going to give us the amount of elements that we want to delete. It'll delete this value right here, right minus left, will be enough elements to delete all of the values until the very end of the array. And after we set that, we then want to set our left and right pointers again. And we will set them to what we initially set them so that they can go back through the array and run the same logical check on the next iteration of the while loop. Okay, so that's our if statement there. Then we have our else statement. And since all of the numbers in the nums array are sorted, we know that nums of left will never equal nums of right. So if nums of left isn't less than nums of right, we know nums of left is greater than nums of right. So in that case, we want to delete nums of left and all the numbers to the left of it, all the elements to the left of it. And how exactly do we do that? Well, dot splice moves from, it deletes values from left to right. We start with our index and it will delete X amount of elements from left to right. So we pass in 0, okay? And then that's our starting point. And we want to delete how many elements? Well, we can say left plus 1. So if we had an array of size 4, just to show this real quick, and this was 11 and 12, let's say, we check to see if 12 is less than 4. It is not, so we want to delete 11 and 12. And since left currently has the value of 1, we just want to increment that by 1 to make it 2 to account for both elements. And we're starting at an index of 0, so we're starting right here. So that's it. Then we want to set our left and right pointers again. And that is the end of our function. So let's go ahead and submit this and make sure that it works. Awesome. First, we want to create our pointers. Left equals math.ceil at nums, or length of nums, divided by 2 minus 1. And so basically here we're setting left to the middle of the array. If the length of the array is odd, it'll be set to the middle element, or the middle indice. And if it is an even length array, then it'll be set to the left middle indice, the left middle index. The right index, or the right pointer, is going to be set to the last index in the array. And now we can open up a while loop. So while length of nums is greater than 1, we will check to see if nums at left is less than nums at right. And if it is, we want to delete all the nums to the right of our left pointer. So the way we can do that is using del, or delete, in Python. So delete, and we'll pass in nums at left. We want to pass in the indices to delete, right? So we want to say left plus 1. So left plus 1 and everything else. And so this colon represents all the way to the end of the array. And then we want to set our left and right pointers again. There we go. Now, else, so if nums at left is greater than nums at right, we want to delete from the very beginning. We want to delete the left pointer and everything to the left of it. So we can say just like this. And we want to have plus 1 here. The reason we want to have plus 1 is because this is starting from 0 all the way up to, but not including this value, or this indice. So we want to delete left. We don't want to delete to the right of left, but since this is non-inclusive, it won't delete to the right or left. It'll just delete everything before it. And so there we go. We then set our left and right back to their default values for the next iteration in the loop. And after that, we pop out of the loop when our length of numbers is no longer greater than 1, meaning that it's equal to 1 rather. And we return nums at 0. Since there's only one element left, we can safely assume that that element is going to be sitting at index of 0. So let's go ahead and return that and submit our algorithm. Okay. Looks like we've got an issue here. Invalid syntax, left +1. Oh, my mistake. We're supposed to have nums here, so it knows which array it's deleting from. So let's go ahead and submit this. And there we go. So that is find a minimum and rotated sorted array in both JavaScript and Python.